Combine functions. Our objective here, let's use addition, subtraction, multiplication, and division to combine functions. Okay, we're going to take two functions and we're going to create one function using addition, subtraction, multiplication, or division. Okay, so we know a couple things here. We know what a function is. It's a relation in which each component of the domain, each input value, each x value, corresponds to exactly one component of the range, an output value or a y value. And we know that the domain of functions is restricted when fractions and or even roots are involved. We saw that in a previous video. So what does the algebra of all this look like? Well, I did a little copy and paste of a section from a textbook. The algebra of functions, sum, difference, product, and quotient. We've got two functions, f and g. The sum is f plus g, the difference is f minus g, the product is f times g, the quotient is f divided g, etc., etc. The domains we really need to worry about here are the quotient. So f plus g of x is the same as f of x plus g of x. F minus g of x is the same as f of x minus g of x. Product fg of x is f of x times g of x, and the quotient f divided by g of x is the same as f of x divided by g of x, and of course g of x cannot be 0 because dividing by 0 is undefined. Okay, and the domains will come into play if the domain of f and or g is restricted, then the domain of the combined function is restricted. Okay, not particularly complicated thing to figure out. Okay, let's take a look at a few examples here. So I'm going to use f of x as x minus 5 and g of x as x squared minus 1. And I want to find each of the following. We're going to do a sum, a difference, a product, and a quotient, and determine their domain. The domain. Okay, so note, if the domains are restricted, okay, the domain of the outcome, okay, the domain of the composition, the combination, the domain of the outcome, all right, is where the domains intersect. And we'll see that in our division problem. Okay, so let's first do a combination using addition, f plus g of x. Well, what do we know? From right up here, and let me come down a touch so we can see it, f plus g of x is equal to f of x plus g of x. So f plus g of x is equal to f of x plus g of x. Now we're going to note that there's no fractions or even roots, so our domains are all real numbers. Okay, so what is f of x? And I like to use parentheses first because, again, with subtraction, it'll make a difference, but it just keeps things clearer. F of x is x minus 5. We're going to add that to g of x, which is x squared minus 1. Okay, we're going to add them together. Well, this just comes out to be x squared plus x minus 6. Okay, and the domain, well, the domains of the two of them were all real numbers. We add them together, we look at the domain, it's still all real numbers. So negative infinity to infinity is the domain. Okay, we want to keep these two functions in mind as we go to the next three examples. Okay, allow me to flip pages and get my next sheet of paper. Okay, it might help us. Let's do this. Let's go to the top of this. It'll help us a little bit here since we're on 2 pieces of paper. Let's remind ourselves that f of x is equal to x minus 5, and g of x is equal to x squared minus 1. Make our lives a little easier than flipping back and forth on to the other side of the page. So now let's do subtraction. Let's combine these 2 functions by subtraction, and we know that f minus g of x is equal to f of x minus g of x. When subtraction's involved, we need to be careful. That's why I'm big on parentheses. Well, f of x is x minus 5. Again, I'll use parentheses. I'm going to subtract the entire g of x function. There's parentheses, so I distribute the negative. X squared minus 1. And then I combine them. Well, I have a negative of x squared. I have a positive x. And then I have a negative 4. Okay, what's the domain? Well, the domain for these 2 is all real numbers. I look at the composite. I don't have a fraction or even root. So the domain is negative infinity to infinity. Okay, let's do the same thing now and multiply f times g of x. Okay, we know that f times g of x is the same thing as f of x times g of x. Let's use our parentheses. F of x, x minus 5, g of x, x squared minus 1. We can do our math and we come up with, I've already done it, it's x cubed, minus 5x squared minus x, hope that's right, yep, and plus 5. Okay, what's our domain? Well, the domain of these 2 is all real numbers. This doesn't have any fractions or even roots in it. So we're still with a domain here of all real numbers. Okay, last one here. We can do some division. Now, once we're doing division, we need to be thinking to ourselves, say, wait a minute. Okay, we're going to divide. We need to be careful about 0 in the denominator. So f of g of x, I'm going to save myself a little bit of space here, is the same as f of x over g of x. Okay, that means we have x minus 5, that's f of x, over g of x is x squared minus 1. So there we have it, okay? So that's f divided by g of x is here. Now we noted that the domain of this was all real numbers, the domain of this is all real numbers, but now we have a function, we've combined it with division, and we have a denominator, we have a fraction. Okay, so we're going to say right here, we have a fraction. We combined it and we got a fraction, and we know what that tells us. The denominator cannot be 0. Okay, so let's take a look at our denominator. X squared minus 1. When is it 0? Well, this is the difference of squares, so we'll factor this as x minus 1 times x plus 1. And we know that x minus 1 can be 0, or x plus 1 can be 0 according to the zero product property. So the denominator is 0 when x equals 1 or x equals negative 1. Okay? So we can't, these 2 numbers can't be involved. So now we talked about where the domains intersect. Well, this one is all reals. This one is all reals. Well, this one says you got to take a couple of things out. Okay, so they intersect according to this one because this pulls out 2 numbers. Okay, so the domain here, and I'll write down the domain equals, well, we're going to go from negative infinity to negative 1. Okay, anything below negative 1 works, but negative 1 does not work. We're going to union that, negative 1 to positive 1, and then we're going to union that from 1 to positive infinity. So this takes out the negative 1, and this takes out the positive 1 here in that domain. Now notice, again, I want to point out, by itself, the domain of the f function was all real numbers. By itself, the domain of the g function was all real numbers. Once we divided them, the domain got restricted because 1 and -1 got taken out because they result in a zero denominator. And so we had to take the most restrictive domain, which is the intersection of all three of them. And we'll see kind of intersection on this example 2, another way to look at it. Okay, speaking of example 2, let's go there. Let f of x equal the square root of x plus 3 and g of x equal the square root of x minus 2. Find the sum of those and find the domain of f plus g. Okay, well, we can already see we've got even roots, so we know some things are going to happen here. Let's first find f plus g. Okay, so letter A. F plus g of x is equal to f of x plus g of x, which is, I'll do this to the right so I can save myself some space, the square root of x plus 3 plus the square root of x minus 2. Okay, well, that's as far as we can go. We can't add square roots like that, so that's not going to happen. So the domain. Okay, so we want to recognize we have even roots. So the domain, we have even roots. Okay, so we know that means our radicand radicands has to be greater than or equal to 0. Okay, nothing's going on here with fractions, so we're only worried about the fact that these two things, the radicand here and the radicand here, must be greater than or equal to 0. So let's see, we know that x plus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to -3. And we know that x minus 2 has to be greater than or equal to 0, so x must be greater than or equal to 2. Okay, let's look at this on a number line. Okay, so we'll put this down here. Okay, here's -3, and here is, okay, this is the domain of the f function, greater than or equal to -3. Okay, we'll put a 2 here. This is the domain of the g function, greater than or equal to 2. Well, where do they intersect? What is the most restrictive? Well, they don't intersect in here because a number like 0 works for f, but it doesn't work for g, and it has to work for everything. So this is where all these two they intersect. Okay, this is the most restrictive. This is the domain of, well, in this case, f plus g. Okay, so what's our domain? Okay, well, the domain is, well, we got 2, and we can include 2 all the way to positive infinity. Okay, unfortunately, the domain of f doesn't really matter in this case because the domain of g is more restrictive than the domain of f. So we have to go with g's domain. We have to go with the most restrictive domain. The domain has to work for all functions involved. So this is the domain of f plus g right here. So there you have it. Keeping an eye on domains, again, with fractions and even radicals.